Hi guys, so today I wanted to show you some of what we'll be doing in the coming lessons, sketching polynomials. Now what I want to try and sketch today is this particular polynomial, which isn't really a polynomial, is it? But anyway, question, why is it not a polynomial? It's a rational function, but it's not a polynomial. So not a polynomial because of the thing on the bottom, right? If it was just the thing on the top, it would be a polynomial, but it's not. Anyway, bit of a sidebar, bit of a realization that the topic is maybe not exactly called sketching polynomials, but anyway, I'd like you to pause the video now and attempt to sketch that using the techniques that you know about from previous stuff, and then I'd like you to come back and watch the rest of the video where I talk about some different techniques that we might be able to use for this kind of polynomial. Okay, so I hope you've paused it now, and I'm going to show you the new techniques now. So what we're going to do is we're going to use polynomial division. We're going to use polynomial division, and then we're going to do what's called oblique asymptotes. We've actually done one of these in the past, if you remember, sketching x squared plus, I think it was 1 on x squared. We have done this kind of sketch before, and that's effectively the technique we're going to be using. But first of all, we're going to do polynomial division. We're going to divide the top thing by the bottom. So let's do that hopefully quickly. I haven't actually calculated the numbers. While I do this, I should talk about what you would have done hopefully. Hopefully you would have got the vertical asymptote at 1. Sorry, you would have factorized the top and seen that it had roots at 4 and 2. And then, so you would have had your zeros, you would have done your infinity analysis, and you would have drawn a curve. And maybe you've checked on Desmos whether it worked, maybe you haven't. If you haven't yet, don't yet. I'll get you to check that a bit later on. So, as I'm going, feel free to do this on your own paper while I go. That's a 5, despite what it might look like. So it's minus 5x plus 5. So it's remainder 3. So what that means is it means that I can write the polynomial as y equals, again, not a polynomial, but anyway, x minus 5 plus 3 over x minus 1. If you don't understand that, pause and try and understand it. I don't want to go through it right now. I'll go through it in class tomorrow, but pause until hopefully you can understand how I got that curve. Okay, so now I'm going to attempt to sketch it, and I'd like you to attempt to do the same. So it would be a good idea again to pause and to try and sketch it using some different techniques, remembering the x squared plus 1 on x squared to curve, and then come back and watch the rest. Okay, so I'm hoping you've had another shot at it, so I'm going to do my best with my iPad to sketch it now, and before I do anything I might just get rid of some of this stuff that I don't want anymore. Okay, try again. There we go. Alright, so what I'm going to do is in green, I'm going to sketch the line x minus 5. Where those numbers are 5, I'm just not going to mark them in. And in, I don't know, whatever this colour is, cerise, I guess. If you happen to be a Joey's boy watching this. I'm going to sketch the curve x minus 1. So that's just a hyperbola shifted to the right 1 unit, right? Now I apologise again. My finger is not the ideal writing tool on the iPad. But anyway. So, in, what colour do I feel like? I feel like an orange. In orange, I'm going to draw the final curve. So essentially what I do is I'm saying I'm adding the pink and the green curves together. Now the way to think about it is to think about adding the y coordinates of the green and the pink curves. So over here, the green curve is a small negative number. And I'm actually going to adjust my curve a little bit just because of a point that I know I want to make in a second, sorry. Whoops. I want to get a bit closer to the asymptote if I can. There we go. So the green curve is a small negative number at the start, just next to the asymptote. So it's going to be adding a negative number to a very large pink number. Right? So that means that the curve is going to be essentially the same as the pink curve, but it should be very slightly below it. And again, it's almost impossible to manage that with my finger. Then at this point here, the x-intercept, of the green curve, the orange curve and the pink curve should match, because the green curve has a y value of 0 that I'm adding to the pink curve. So I should pass through the pink curve there. And I'm going to redo that in a second, because it's a terrible drawing, but it's beside the point at this point. Over here, the pink curve is 0. And I'm adding the green curve, I'm adding 0 to the green curve. But the important thing is I'm adding a positive 0 value. So I'm always above the green curve, but I get very close to it. Here is kind of also a critical point, not necessarily a turning point, but I mean critical in the point in the sense of it's important. The y value at whatever this x value here is, it might be 10 or something. You can calculate it by equating the two curves. It should be double whatever that is. So it should be here, roughly. Okay. So I'm going to try and draw all those features together after I get rid of a few things. So it should be something like that. Okay, so kind of a parabolic shape with those important oblique asymptotes. Have I used that word? I think I did earlier. The oblique asymptotes are the two curves, the green and the pink. Over here, orange is essentially the same as green. That's the oblique asymptote there. Over here, orange is essentially the same as pink. That's the oblique asymptote there. These two things here are the oblique asymptotes. They're the two key components to the curve. I can do exactly the same thing down here. So, I'm saying down here and pointing to my iPad screen stupidly. So at this asymptote, green is basically 0. It's a negative number. Pink is also a negative number. So when I add them together, I get a bigger negative number. So my orange should be below it, but only slightly below it, because pink is essentially, 100 million, and green is -4. So the -4 does nothing. The y-intercept should be, add the two y-intercepts together, whatever they are. That's -5, that is -3, so it should be -8. Okay, again, I'll do this in more detail on the board tomorrow. Here, should be double, so about there. Here, pink is 0, add it to green, it's a negative, so it gets a bigger negative, so it looks like that, roughly. Okay, I'd encourage you now to go to Desmos, type in both of these things. First of all, type in both if you're not convinced about the polynomial division, and check that they are equal. But also I'd encourage you to type in the full curve, the black curve, and also the two oblique asymptotes. Notice that the 3 there is included in the oblique asymptote. And try and see this relationship that I've just shown you. Alright, I hope you've had a good holiday. I'll see you tomorrow.